Hello and welcome to another maths lesson. So today we are doing standard index form. Lesson 1, converting between normal and standard index form. I'm Dr. Islam and let's get on with it. So our learning intentions for today are to understand standard index form, to be able to convert numbers into standard form, and to be able to convert numbers from standard form to normal form. So as a starter for standard index form, I'd like you to write these as powers of 10. So you've got the first question is 1,000, 10,000, and so on. In the purple box, I've got 2 extension questions. So pause the video and have a go at writing these numbers as powers of 10. As a little hint, remember that 10 times 10 is equal to 10 squared, which is the same as 100. Okay, here are the answers. So 1,000 is 10 to the power of 3. 10,000 is 10 to the power of 4. Now, can you spot that 10,000 has 4 zeros after the 1? Then we've got in question 3, when we had 6 zeros after the 1, it turned out to be 10 to the power of 6. And question 4 was 10 to the power of 9. Question 5 was 10 to the power of 10. Question 6 was 10 to the power of 20. Now, in question 7, we just have 10. Writing that as a power of 10, well, 10 by itself is equivalent as 10 to the power of 1. And question 8, we had 1. Well, anything to the power of 0 is equal to 1. So 10 to the power of 0 is the same thing as 1. So we can write 1 as a power of 10. So mark your answers, and if you didn't understand those questions, I hope you do now. And that starts us off with the topic. So let's recap. Powers of 10. So if we had 1,000, we could write it as 10 to the power of 3. If we had 100, we could write it as 10 to the power of 2. If we had 10, we could write it as 10 to the power of 1. If we divide that by 10, we get 1. That's the same as 10 to the power of 0. If we divide by 10 again, we get 0.1. That's the same as 10 to the power of minus 1. If we divide by 10 again, we get 0.01. That's the same as 10 to the power of minus 2. So you need to be familiar with this before you start work on standard index form. You need to be happy with what powers of 10 mean. Okay, so if you're not sure, and if this is a bit new, write it down in your book, have a piece of pen and a book or an exercise book or a piece of paper handy and make some notes. So let's have a look at 2 numbers. We have got this number, and we've got this number. So, how could we say these numbers? Could we enter these numbers in a calculator? What could these numbers represent? Time for you to have a little think about those questions before we go any further. Well, how many cells are there in the human body? It's estimated that there were around 30 trillion cells in the human body. And that's a very large number. Well, the second number we had was incredibly small, and that could represent the mass of 1 oxygen atom in grams. So, what is standard index form? Well, it's a way of efficiently representing large and very, very small numbers in the form a times 10 to the power of b. So, what do we need to know about a and b? Well, we have a digit term a, and this digit term has to be greater than or equal to 1, but less than 10. We have an exponential term 10 to the power of b. So b is a positive or negative integer. So examples from before, those two numbers written in standard form, well, 30 trillion can be written as 3 times 10 to the power of 13, and the weight of an oxygen atom in grams can be written as 3 times 10 to the power of minus 23. Very, very small. So let's look at this further. Okie dokie, so we need to be able to convert a normal number to standard index form. Let's have a look at an example. Write 300,000 in standard form. Well, what do we know about the first part of the number? That according to the rules of standard index form, what does that first part of the number have to be? Well, that first part of the number, that digit term, has to be between 1 and 10. So in this case, we'll choose 3. Next, starting with 3, how many times do we have to multiply by 10 to get to 300,000? Well, let's do the whole working out. We would need to do 3 times 10 times 10 times 10 times 10 and times 10 again. So to get that final exponent term, we would have standard index form as 3 times 10 to the power of 5. So writing 300,000 in standard index form is 3 times 10 to the power of 5. So first of all, we got our digit term, that 3, because it was between 1 and 10. Then we worked out our exponent term, and that happened to be 10 to the power of 5. What about converting a normal number to standard index form when you've got something like this? 310,000, write that into standard index form. Well, when we had 300,000, it was 3 times 10 to the power of 5. This time, we will have that digit term would be 3.1. So it's 3.1 times 10 to the power of 5. Check. Does this make sense? 10 to the power of 5 is 100,000, so 3.1 times 100,000 is 310,000. So if there are numbers that are not zeros, these all need to be written so you don't lose the accuracy in the final answer. So let's have another look at converting a number from standard index form into normal form. So here's an example. Consider 9 times 10 to the power of 4. How would we write this number in normal form? Well, think about what this means. It means 9 times 10 times 10 times 10 times 10. So it's going to be a big number. So 9 times 10 would give us 90 times, if we do that first part, but then we've still got to times it by 10 again. We get 900, but we've still got to times it by 10 again, and we get 9,000, and we have to times it by 10 again, and we end up with 90,000. Did you spot that the number of zeros after the 9 are the same as the number that the 10 was raised to? That makes sense because by timesing by 10 enlarges the number by a factor of 10. So so the numbers get bigger away from the decimal point. Okay. So another way to think about this, so say you'd been asked to convert 9 times 10 to the power of 4, is the power of 10 is positive, it's positive 4, meaning that the number is a big number. So we look at the 9 and we think about where the decimal point would be. So the decimal point now needs to be moved 4 places to the right in order to make the number 10,000 times bigger. So we end up with 90,000. That's another way of thinking about it. So, what about converting from standard index form into normal form? Right, so we've got a number here, 9.87 times 10 to the power of 5. How would we write this in normal form? Well, what I'm going to do is I'm going to show you what this really means in a long method, just to show you, to prove that I know so that you know what's going on. So we've got 9.87 times lots of tens, 5 of those. So you could times by 10 and you'd end up with this. You could times by one of the tens and then you'd end up with this. You could times by 10 and you'd end up with this. And you times by one of those tens and you end up with this. And multiplying by the last 10, you'd end up with 987,000. Okay, but what about a very small number? Converting a normal number into standard index form. Well, I'd like you to look at this example. We've got the number 0.0006, so it's a small number. How do we write this in standard index form? Well, first we need to decide what our digit is going to be. Remember, our digit has to be between 1 and 10, so in this case, it will be 6. Now, we need to decide what the exponent part of the standard index form is. It's times 10 to the power of something. Now, when it's a small number, we need to raise 10 to the power of a negative number. So in this case, we are going to raise it to 6 times 10 to the power of minus 4. Now, does this make sense? Well, you need to be really confident with what 10 to the power of minus 4 means. Well, 10 to the power of minus 4, remember, a negative index, a negative power is the same as a division, a reciprocal. So it's the same as 0.0001. So that negative power gives you a reciprocal 1 over 10 to the power of 4. And that can be written as a decimal 0.0001. So 6 times 0.0001 is 0.0006. It's really important that you are comfortable with raising 10 to the powers of positive numbers and 10 to the powers of negative numbers. Is 56.7 times 10 to the power of 4 written in standard form? Yes or no? The answer is no, it's not. And why is it not? Well, when you write in standard form, the digit needs to be between 1 and 10, but 56.7 is greater than 10. So therefore, it's not in standard form. So how would we deal with this situation? Well, remember, the first number, that digit term, needs to be between 1 and 10. So how would we adjust this to make it into standard form? Well, if we've got 56.7 times 10 to the power of 4, we could consider that it's 56.7 times 10 times 10 times 10 times 10, which is 567,000. And that, written in standard form, is 5.6 times 10 to the power of 5.67 times 10 to the power of 1, 2, 3, 4, 5. So another way to think about this is that we need to make this digit smaller. We're dividing by 10 to make it 5.67. But with the power of 10, we need to times that by 10, because you can't just divide by 10. You need the number to stay the same. So to keep it balanced, when you divide that 56.7 by 10, that means you need to actually multiply by another 10 so that you haven't changed the overall number. So we've adjusted by dividing 56.7 by 10 to make it 5.67, and then adjusted by timesing the 10 to the power of 4, by timesing by 10 again, and you end up with 5 0.67 times 10 to the power of 5. Okay, because the number has to stay the same, you've divided by 10 with the to make the digit 5.67, so you can't just leave it like that. You have to multiply by 10 as well, because the number has to be the same. So well done for your attention today. So hopefully you understand about standard index form, and you can convert numbers from normal form into standard index form, and you can convert numbers from standard index form to normal form. What I suggest you do now, after watching this video, is do some practice questions to really test your skills.